Imagine you drop a glass on the floor. It shatters into 100 pieces. Now here's the weird thing. You've never seen those pieces jump back up and reassemble themselves. Never. But why not? The laws of physics don't actually forbid it. Every collision, every force, every interaction could theoretically run backward. Think about a movie of a pendulum swinging. Play it forward, play it backward. You can't tell which is which. But now think about a movie of an egg breaking. Played backward, it looks ridiculous. So what's the difference? Let me tell you about your messy bedroom. There's one way for it to be perfectly organized. But there are millions of ways for it to be messy. Millions. If you just randomly move things around, you'll almost always make it messier. Not because there's a law against tidiness, but because messiness has so many more possibilities. The universe is the same way. Things spread out. Energy disperses. Heat flows from hot to cold. Not because they have to, but because there are so many more ways to be spread out than concentrated. Now, let's talk about what's really happening. This is entropy. Entropy is a measure of disorder, yes, but more precisely, it's a measure of possibility. The second law of thermodynamics says entropy always increases in a closed system. Always. That broken glass has trillions of atoms. Each atom is moving, vibrating, bouncing off others. The number of ways those atoms can be arranged while still being broken glass is astronomical. The number of ways they can be arranged to form a perfect, intact glass is tiny. Vanishingly tiny. Time's arrow isn't written into the fundamental equations. Newton's laws work equally well forward and backward. So does Schrödinger's equation. But when you have billions and billions of particles, statistics takes over. The system will almost certainly evolve toward states with higher entropy. Not because low entropy states are forbidden, but because they're improbable. Here's the deep part. Time doesn't move forward. Entropy increases, and we call that direction forward. Our memories are physical structures in our brains. They're low entropy configurations that formed as entropy increased around them. We remember the past because the past was lower entropy. The universe started in an incredibly low entropy state at the Big Bang. Since then, it's been spreading out, evening out, increasing entropy. And that process, that one-way journey from order to disorder, is what we experience as time. The arrow of time is just entropy, unfolding. And we're the pattern that arose along the way, noticing the journey.